Hello everyone, good morning. Welcome you all on Unacademy, India's largest learning platform. So, first of all, a little bit of introduction, then we will start the session. Myself, Dr. Nidhi, I am your physiology educator at Unacademy. This is our Telegram page. You can join us out here. Our Telegram page is Let's Crack NEET PG. You will get link of every classes out here. This is my page on Unacademy, that is unacademy.com/@KGMC. You can follow me out there so that you will get notification of any upcoming classes of mine. This is the code Dr. Nidhi. If you want to join any paid course, you can use this referral code to get additional 10% off. I have taken many plus classes, many special classes, so anytime you can join and revise your topic. This is the free test for the upcoming week, that is week 4 of the April. So do give the test, because giving the test is important, because from that you analyze your preparation at any point of time. These tests are free of cost. For unlock, you have to use the code, that is Dr. Nidhi. By using this code, your all the free tests will be unlocked. Moving further, we have a two type of subscription: plus subscription as well as iconic subscription. First, coming to this plus subscription, what all are the benefit? You will be able to access both the live and recorded session. By chance, if you miss any session, you can see the recorded version. You have an opportunity to learn from India's top educator for the medical examination. We always conduct this in live tests and live quizzes. From that, you can analyze your preparation at any point of time. You have a flexibility. You can study on the device of your choice. You always carry your phone with yourself, so you can access your class from anywhere. So moving, we have a question bank which consists of 25,000 plus question. High yield questions are there, clinical based questions are there, and this is with explanation. So that is going to be very beneficial for all of you. Next is the iconic subscription, where you get access of India's two best platform, that is Unacademy and the Prep Ladder. So you are going to get all the Unacademy plus benefit. Like I said, live classes, recorded classes, question bank, live tests, live quizzes. Along with that, you get access for this Prep Ladder. In this, you can access the clinical and integrated essential of Prep Ladder, video lecture from the Dream Team, question point 3.0 with active guidance, rapid revision and snapshot, and you will also be provided with their treasure and dream notes. So if you want to access the Prep Ladder also, go for the iconic subscription, everybody. Moving further, we are launched with this Unacademy Lite for the NEET PG. In this, you can access all the test series like subject voice test, system voice test, full length mock test paper, previous year questions, test series curated by the top educator. In this, you will be also given access for the grant test for NEET PG, INSET, FMG. So moving further, we are started with this MBBS first prof. So if you are in your first prof, you can join this batch. 3-month fee is 5,500, but the pre-launch price is 4,950 only. 6-month fee is 10,000, but the pre-launch price is only 9,000. 12-month fee is 12,000, but the pre-launch price is only and only 10,800. So you can enroll yourself in this batch. If you are in the first prof, you will be able to ace your first prof also, plus you will be able to access the next examination also. We have started with this auto daily practice paper. After every plus classes, you will be getting the 5 to 10 question which is handpicked by your educator, and that will be related to the topic discussed in that session. So that is going to help you to enhance your concepts. We have started with this doubt clarification batch also. Moving further, they are our FMG December 2021 topper. Now coming to the special class feature. Our special class are way more special than the YouTube channel, because our special class is always and always live. Live interactive sessions are there, polls features are there, that from that you can better understand your topic. Raise a hand features there. Now you can talk to your educator in the live session, clear a doubt in live session. If you follow any educator, you will get notification of their upcoming courses, and after the lecture, you can download the PDF and revise it anytime, anywhere. We are started with this all educator revision batch. So if anybody is targeting this NEET PG 2022, you can enroll yourself in this batch. We are started with this MBBS first year foundation batch. As I said, in this all the basic of anatomy, physiology and biochem will be covered, and that is also covering this practical and viva guidance, answer writing guidance session will also be there. So 120 hour of revision will be there. All the subject tests will be included in this one. Live interactive session with the top educator, and you will get the doubt clarification session. Along with that, you have a feature that is a raise a hand feature. From that, you can use and clear doubts in the live session only. This is the fee structure for the plus subscription. This is the fee structure for the iconic subscription, and this is the fee structure for the light subscription. Moving further to our topic, today we are going to study about the membranal transport. First, coming to the transport process in the membrane. The protein that are responsible for transports are, first is the pores, then channel, then we have a carrier, and then we have a pump. Now coming to the detail of each transport protein, first is the pore. This pore is always and always open. This transmembrane protein is always and always open. And in examples, we have this aquaporin. In this, we have aquaporin, perforin, and they are responsible for water movements. So do remember the important point, that is pore is always and always open. Next is our channel protein. This channel protein, this is also a transport membrane protein, and this transport the substances by using the simple diffusion. In this, we have various type of channel protein, like the leaky channel. We have so we have this sodium leaky channel, which is present in all cells, is a classical example of our leaky channel. Next is the gated channels. In this, we have various type of gated channel. First is the voltage gated ion channel. For example, we have voltage gated sodium channel, we have voltage gated potassium channel, we have voltage gated calcium channel. So they are the classical example of voltage gated ion channel. Next is the ligand gated ion channel. Means these channels are gated by certain ligands. In presence of that ligand only, they will open up. So this ligand gated ion channel is also known as ionotropic receptor associated channels. In this, we have this GABA A and nicotinic acetylcholine receptor. Next one is the cyclic nucleotide gated channel. Means this channel are gated by the cyclic nucleotide. Whenever there is rise in the cyclic nucleotide, only then this channel will open up. So we have this cyclic nucleotide gated channel. In this, we have a G protein coupled receptor. For example, we have this GABA B and muscarinic acetylcholine receptor, NR, it's CN channel. This Estrogen channel, its full name is hyperpolarization activated cyclic nucleotide gated channel. This channel is also known as the funny channel, and this channel is classically present in our SA node. And in SA node, this channel is responsible for, do remember, in SA node it is responsible for this pre-potential. Is this clear with everybody? So this Estrogen channel is important. Do remember everyone. So moving further, this Estrogen channel is known as hyperpolarization activated cyclic nucleotide channel. So more the presence of the cyclic nucleotide is there, more activation of this channel will occur. Hyperpolarization activated means more the hyperpolarization, more is the activation of this Estrogen channel. So that's why it is known as hyperpolarization activated cyclic nucleotide gated channels. Is this clear? So we have voltage gated channel, we have leaky channels, and we have cyclic nucleotide gated channel. And next one is the time gated channel. Some channel open up slowly, some channel open up fast. So these are time gated channel. In this, we have slow calcium channel in our heart, potassium channel in our nerve membrane are the classical example of a time gated channel. Next is the mechanically gated channel. In this, the touch receptor which is present in the skin, they are open up when there is a mechanical stimulation that like touch. So they are known as the mechanically gated channels. And the last one is our chemical gated channels. Means these channels are gated by certain chemicals. Only in the presence of this chemical, this channel will open up. So for example, we have the classical example out here. that is oxygen sensitive potassium channel and ATP sensitive potassium channel. This oxygen sensitive potassium channel is present in our carotid body and the erythropoietin synthesizing cells in our kidney, and beside that it is also present in our lung. So do remember, these are the classical example where this oxygen sensitive potassium channel are present. That is in lung, carotid body and erythropoietin synthesizing cells in our kidney. Next is this ATP sensitive potassium channel. They are classically present in pancreatic beta cell and they are responsible for insulin release from pancreatic beta cell. How they are responsible? See, what happened? When glucose enters into the beta pancreatic cell, glycolysis will occur, and due to glycolysis there will be the release of this ATP, and in presence of this ATP sensitive potassium channel will get closed, not open up, it get closed. And due to the closure of ATP sensitive potassium channel, let me draw the diagram for all of you. Suppose this is a beta pancreatic cell and this is ATP sensitive potassium channel. So what happened? When there is a glucose in our blood vessel, this glucose diffuses and it reaches to the beta pancreatic cells. In beta pancreatic cell, the glycolysis will occur and ATP will be released. This ATP is going to cause this closure of ATP sensitive potassium channel. Due to the closure of potassium sensitive and ATP sensitive potassium channel, this potassium efflux will stop. So that's why potassium will start accumulating inside the cell. And we all know resting membrane of any membrane, the resting potential is negative. When positive ion accumulate inside the cell, the negativity inside the cell is going to decrease. So the resting membrane potential of our beta pancreatic cell is a minus 70 millivolt. And when it decreases to minus 40 millivolt, okay, this membrane potential increases, not decreases, sorry, it increases. Negativity decreases, but the membrane potential obviously increases. So when it increases to minus 40 millivolt, the voltage gated calcium channel open up. Do you remember our calcium channel open up at minus 40 millivolt? So at minus 40 millivolt, this calcium channel will open up. And due to opening of this voltage gated calcium channel, calcium influx will start. And this calcium is responsible for exocytosis of insulin. Do remember the exocytosis process always and always need this calcium, intracellular calcium. So that's how our ATP sensitive potassium channel is responsible for insulin release from the beta pancreatic cell. Is this clear with everybody? Do you reply fast? Okay, fine. So moving further. Now coming to the after pump channel, we have this carrier molecule. This carrier molecule is also known as a transporters. So this carrier molecule is required for this facilitated diffusion and the secondary active transport. We will discuss this one also in today's session, which type of transport are there. First we are covering this transport protein, then we will cover this all the type of transport process. So for till now you remember this one. The carrier are involved in the facilitated diffusion as well as secondary active transport. It can be the symport or antiport. Both require this carrier molecule or the transporter. And wherever this carrier mediated transport is there, three characteristic feature will be seen. That is stereospecificity, means they will be stereospecific. Either it is allowing the D isomer or the L isomer. Only one thing will be transported, so they will be the stereospecific. Only if it allowing D isomer, it is not allowing this L isomer. If it is allowing this L isomer, then it is not allowing this D isomer. So they will be showing this characteristic feature, that is stereospecificity. And they will also see this saturation stage, because after certain period of time, what happened, all the carrier molecule will be involved, and after that what happened, when we increase the concentration, the rate of transport doesn't increase. Let me draw this one for all of you so that you can better understand this one. On x-axis we take the concentration, on y-axis we take the transport. So what happened when carrier or transporter is involved? Initially, when we increase the concentration of substance, rate of transport increases. But after a certain period of time, what happened? This rate of transport become constant because all the carrier molecule will be involved. So this is the saturation we will see in this carrier mediated transport. Next is the competition. They will show this competition also. All the carrier mediated transport will show this three characteristic feature: stereospecificity, saturation, and the competition. And do remember, this carriers are involved in facilitated diffusion as well as secondary active transport, that is both symport as well as antiport. Is this clear? So moving further, this is a very important. Glucose transport in all the cell occur via the blood. That is a glucose transporter. Different type of glucose transporters are there. So glucose transport in all of the cell occur via this glucose transporter, and this glucose transporter is an example of facilitated diffusion. But there is an exception, that is a GIT and the kidney. In GI and in the kidney, this occur via the sodium glucose co-transporter, SGLT, that is the sodium glucose co-transporter. So this exception is there. In GIT and in kidney, this glucose transport occur via the sodium glucose co-transporter, which is a classical example of secondary active transport. Do remember this one. Is this clear with everybody? So moving further to the last transport protein present in our cell membrane is our pump. They are also known as ATPase. This pump is characteristically required for primary active transport. And what happened? How this pump works? The ATP binding is there, ATP breakdown is there, and that energy is provided, and that energy is directly utilized by this pump. For example, we have the sodium potassium pump and the Sarka pump. Is this clear with everyone? Do you reply fast? Is this clear? So we are covered with all these channel proteins present in our membrane. That is the pore, channel, carrier, pump. Pore are always and always open. Channels are various type of channels are there. Ligand-gated channel is there. Leaky channel is there. Voltage-gated channel are there. And next one is the carrier molecules are there. So carrier are required for, everybody do reply fast. Carrier are required for which type of transport? Do reply fast. Carrier are required for facilitated diffusion as well as secondary active transport. Yeah, way true. And pumps are required for primary active transport. For simple diffusion, channels are involved. Is this clear? So moving further to the classical example, that is first coming to this transport process. Okay, one sec everybody. One second. Okay, we will see this one in the later slides. So first taking you to this slide, that is various type of transport process are there. That is, first is the transport through the membrane. And another category is the transport across the membrane. In this, it is also known as the vesicular transport. In this, we have endocytosis as well as exocytosis. First, coming to this transport through the membrane. The transport through the membrane can be either with the use of ATP, that is known as active transport, and without use of ATP, that is known as the passive transport. This passive transport can be the via this diffusion or the osmosis. This diffusion can be either simple diffusion or the facilitated diffusion. Okay. Next is the active transport, which required ATP can be either the primary active transport or the secondary active transport. Now moving to each and every part in the detail. First coming to this vesicular transport. In this first one is endocytosis. When something is taken inside the cell, it is known as endocytosis. It can be the large molecule or the foreign substance which is taken inside the cell is known as endocytosis. It is further classified into three types. That is the phagocytosis, which is also known as cellular eating. Next is the pinocytosis, which is also known as cellular drinking. Next one is the clathrin mediated endocytosis. So do remember, endocytosis means something is taken inside the cell, like large molecule or foreign substance is taken inside the cell. The process is known as endocytosis. Next is the exocytosis. In exocytosis, substance are removed from the cells. So that's why it is also known as a cellular vomiting. Now coming to the mechanism part, how this exocytosis occurs. We all know the protein synthesis occur in raw endoplasmic reticulum. So first point is this protein synthesis occur in raw endoplasmic reticulum. So what happened is from there it goes to the Golgi apparatus for the modification of protein. So modification of protein basically occur in the Golgi apparatus. So this Golgi apparatus is going to modify the protein and it is going to release the protein. And this release of protein is in the form of secretory vesicle. And this release of protein in the form of secretory vesicle are the classical example of exocytosis. Is this clear with everybody? Do reply fast. Is this clear? Okay, Okay, fine. Moving further, the exocytosis can be either via two pathways, that is the constitutive pathway or the regulated pathway. So what happened in constitutive pathway? What happened in this regulated pathway? In a constitutive pathway, the vesicle form and it is going to fuse spontaneously with the plasma membrane. So the classical example are mucus secretion from all our goblet cells, immunoglobulin secretion by the plasma cell. They all occur via this constitutive pathway, means vesicular form, and they are going to the plasma membrane and they spontaneously fuse with the plasma membrane in exocytosis occur. Now coming to the regulated pathway. What happened in regulated pathway? Something is regulating this exocytosis. So out here certain triggers are signaling this exocytosis, such as our hormones. So they are coming under this regulated pathway. Those exocytosis which is regulated, which is triggered by certain signals like hormones, are coming under this category, that is the regulated exocytosis. In this, the classical example are neurotransmitter secretion at the synapse and the hormonal secretion. They are the classical example of regulated pathway. Do remember, in regulated pathway, there is certain trigger which is going to stimulate the exocytosis. Moving further, this is the exception part. So do remember, all the exocytosis already discussed, I guess. All the exocytosis is requiring this increase in cytoplasmic calcium, but there is an exception. The parathormone secretion and the renin secretion by the Ig cell doesn't require this increase in intracytoplasmic calcium. So do remember this exception part also. So moving further, now coming to the detail of our membranal transport, that is through the membrane. That is first coming to this passive transport, which doesn't require any energy. So out here no ATP is required, and this first one is a simple diffusion. How this diffusion occurs? So what happened? The diffusion occur. Normally the diffusion occur from higher concentration to the lower concentration. So this is the diffusion occurring from higher concentration to the lower concentration, and this concentration gradient is forming the kinetic energy. This concentration gradient is forming this kinetic energy. One sec. This concentration gradient is forming this kinetic energy, and this kinetic energy is driving the force for this diffusion. So do remember, diffusion required the concentration gradient, and diffusion always occur along the concentration gradient. Either it is a concentration gradient or electrical gradient, diffusion occur along the gradient. Is this clear? Out here no carrier molecule are involved. So since no carrier molecule are involved, our transport maximum is not there, and there will be no saturation. When we increase the concentration, the rate of transport is going to increase in this situation. So this is the graph for this one. On x-axis we are taking the concentration, on a y-axis we are taking the transport, and in simple diffusion, since no carrier molecule is involved, when we increase the concentration, transport is going to increase. Is this clear with everybody? So the classical example are diffusion of gases in the lung. They are the classical example. Diffusion, exchange of gases in the lungs, like oxygen exchange from our lungs to the blood vessels. From blood vessel, carbon dioxide is removed to the lung. They are the classical example of simple diffusion. And do remember, diffusion always and always follows this Fick's law. What does the Fick's law state? Fick's law state that the diffusion is directly proportional to the concentration gradient. Means more the concentration gradient is there, more will be the rate of diffusion. Diffusion is inversely proportional to the thickness of membrane. More the thickness of membrane, lesser will be the diffusion. It is directly proportional to the solubility of substance. More the substance is lipid is soluble, more will be the rate of diffusion. Diffusion is inversely proportional to the size of molecule. More the size of molecule, lesser will be the diffusion. So this is our Fick's law. Do remember, everybody. Is this clear with everybody? All the points regarding this simple diffusion. Is this clear? Do you reply fast? Is this clear with everyone? Okay, fine. Moving further. To the next one, that is a facilitated diffusion. This is also a passive process. So out here also no energy is required. No ATP is required out here. But the carrier molecule are involved out here. Remember the channels, the carrier molecules, which is also known as transporter, are involved in facilitated diffusion. So out here there will be concept of B max or transport max. Initially when we increase the concentration gradient, rate of transport increases. But after a certain period of time, what happened? When we increase the concentration gradient, there is the no more increase in a rate of transport. This is known as a transporter max or V max. This is known as the transporter max, or in short is also known as the V max. So whenever the carrier molecule is involved, there will be the transporter max concept. So out here in facilitated diffusion also there will be the concept of this transporter max. Now coming to the example, glucose transported by the gut are the classical example of this facilitated diffusion. Water transport via this aquaporin is also a classical example of facilitated diffusion. Do remember these two things. The examples are very important. Coming to the next one, that is the last of passive process. Passive transport process is the osmosis. What happened in osmosis? In osmosis, see, this is the diagram. Suppose this is a chamber, and in this chamber, there is a partition. This is a membranal partition, and this chamber has higher concentration, and this chamber has a lower concentration. So what happened in osmosis? In osmosis, the water molecule moves, and it moves from lower concentration to the higher concentration. So this is the osmosis. Is this clear? What happened in osmosis? You can say higher concentration of both solution. You can say higher concentration of solution or higher concentration of a solute. So water move from lower concentration of solution to the higher concentration of solution in osmosis, or you can say water move from lower concentration of solute to higher concentration of a solute. This is the process which is known as osmosis. In osmosis, there is a concept of bulk flow or solvent drag protein. What happens when water moves in a bulk, it drags sodium along with it. So do remember, whenever water moves in a bulk, it drags sodium along with it, and this is known as a bulk flow or solvent drag protein. Now coming to the example of osmosis, CSF absorption, capillary filtration, and the descending limb of loop of Henle, which is permeable to water, are the classical example of osmosis. Do you remember this example are important? CSF absorption, capillary filtration, and the descending limb of loop of Henle. So the classical example of this osmosis. Moving further to the two terminology, that is osmolarity and osmolality. What is osmolarity and what is this osmolality? Osmolarity is the number of solute per liter of solution. So when we are talking in the terms of liter, that is the number of solutes upon liter in the liter of solution is our osmolarity. What is osmolality? Mass of solute per kg of water. Mass of solute per kg of water is osmolarity. So these two terminology are important. Do remember everybody. Next is the serum osmolality. We can calculate the serum osmolality by this formula. That is, serum osmolality is equal to 2.1 into concentration of sodium plus glucose upon 18 plus blood urea nitrogen upon 28. So this formula is going to give you the serum osmolality. Is this clear with everybody? So we covered all these passive transport, that is simple diffusion, facilitated diffusion, as well as osmosis. So do remember the example, everyone. Moving further to the next one, that is the last one, that is active transport. Means outer energy will be required and this energy is required in the form of ATP. So basically we have two type of active transport, the primary active transport as well as secondary active transport. First coming to this primary active transport. Primary active transport, remember the pump is required, and whenever the pump is required, ATP will bind out directly, hydrolysis of ATP will occur and ATP will be used directly. So these 2 points are important. Active transport, primary active transport required the pump and it used the ATP directly. Classical example are sodium potassium ATPase pump, calcium pump and the proton pump. They are the classical example of primary active transport. Primary active transport required the pump and ATP is used directly. Is this clear with everybody? Do reply fast. Is this clear? Shall we proceed further? Okay, fine. Moving further to the secondary active transport. First, let me take you to the sodium potassium pump in the detail. They are the classical example of the primary active transport. They are the transmembrane protein because they crosses the whole membrane. Suppose this is a cell membrane. So this sodium potassium pump is crossing our whole membrane. So that's why they are the classical example of this transmembrane protein. They are universal because they are ubiquitous, because they are present in all cells. They are known as heterodimer because it is made up of two units, that is alpha and the beta, and both units are different. So it is known as a heterodimer. So now coming to the function of the sodium potassium pump. The sodium potassium pump is responsible for exchange of sodium and the potassium. What does it do? It moves with 3 sodium outside and 2 potassium inside. 3 sodium is pushed outside and 2 potassium is pushed inside the cell. So this is the basic role of the sodium potassium pump. So the coupling ratio of this pump is 3:2. In yesterday's session we studied the major cation in ECFS. Anyone? The major cation in the ECF major cation in the ICF is? Anyone? Do you reply fast? The major cation in ECF, major cation in ICF. Any of you? Dr. Kartika, answer this question. Major cation in the ECF or the major cation in the ICF are? Yeah, very true. The major cation in ECF is sodium. And major cation in the ICF is? Yeah, very true. It is a potassium ion. So what happened? Potassium is pushed in the ECF. This is the ECF and this is the intracellular compartment. This is the ICF. So potassium is the push in ECF, and we all know the the sodium is pushed in the ECF, and the sodium concentration is also more in the ECF. So it is moving the ion in against the gradient. It is moving the ion against the gradient, not along the gradient, because it is moving the sodium in the ECF, and we all know in ECF sodium ion is already more. So it is moving the substance against the gradient, and that's why it required the ATP. Is this clear with everybody? Do reply fast. Is this clear? Is this point clear with everyone? Shall we proceed further? Okay, fine. Moving further, this alpha unit and the beta unit had different sites. This alpha unit as well as beta unit consist of different sites. This beta unit consists of 3 extracellular glycosylation sites. This alpha unit at the extracellular position, it is having this potassium binding site, and along with that it also have this digoxin binding site. In intracellular position, it is going to have the sodium binding site, ATP binding site, and the phosphorylation site. So let me draw this diagram for all of you. This is our beta unit. This beta unit at the extracellular position consists of 3 glycosylation sites. Now drawing this alpha unit. Alpha unit at extracellular position have potassium binding site and the digoxin binding site. And at intracellular position, it consists of 3 sodium binding site, ATP binding site, and the phosphorylation site. So this is the diagram. This is the beta unit, which consists of 3 extracellular glycosylation site, and this is the alpha unit, which at extracellular position consists of 2 potassium binding site, digoxin binding site, and in intracellular position it consists of 3 sodium binding site, ATP binding site, and the phosphorylation site is there. So this is all about the sodium potassium pump. Do remember each and every point regarding this. You can answer the short note from this. Moving further to the last one, that is the secondary active transport. After the primary active transport, coming to the secondary active transport. This secondary active transport is further classified into 2-1, that is symport or antiport. So first coming to the symport. Symporter is also known as a co-transporter. As the name suggests, co-transporter means two substances are moving in the same direction. So this is the symport. Two substances will move in the same direction. And in this we have a classical example. We already discussed sodium glucose co-transporter SGLT1, SGLT1 and SGLT2. They are the classical example of co-transporter. Both the sodium and glucose move inside the cell. So in intestine we have this SGLT1, in kidney we have this SGLT2. So they are classical example of a sodium glucose co-transporter, or classical example of symporter. Coming to the next one, sodium potassium twice chloride co-transporter. It is basically present in our ascending limb of loop of Henle. Do you remember? They are also known as the Barton channel because mutation of this channel lead to the Bartter syndrome, and the sodium potassium twice chloride co-transporter is blocked by this loop diuretics. So for now, till now you will remember the example only. We have the sodium potassium twice chloride co-transporter. We have sodium iodide symporter, which is present in the follicular cell of thyroid gland. So they are basically the classical example of symporter. Is this clear? So moving to the next one, that is antiporter. So this antiporter, what happened? This antiporter, as the name suggests, two substances will move in opposite direction. In this, the classical example is the sodium calcium exchanger, chloride bicarbonate exchanger. They are the classical example of antiporter. So is this clear with everybody? So what is the difference between the primary active transport and the secondary active transport? Let me take you to this one. Primary active transport required the pump and it used the ATP directly. While the secondary active transport required the channel's carrier molecule and ATP is used indirectly. This is the basic difference between the primary active transport and the secondary active transport. Is this clear with everybody? So this is all about the membranal transport. If anybody has any doubt, you can ask. We will see some question regarding this topic only. Do reply fast. If anybody has any doubt, you can ask in the session only. So next, taking to the last topic, that is our Michaelis and Mental Law, that is membrane transport graph. Wherever this channel or the carrier is required, there is a following of this Michaelis-Menten Law. What is this Michaelis-Menten Law state? That initially when we increase the concentration of substance, the rate of transport increases. But after a certain period of time, what happens? Wherever this channel or carrier is involved, after a certain period of time, all the channels will be occupied, and since all the channels are occupied, the transport is not going to increase. So this transport reaches to its maximum, that is known as Vmax or the transport max. Simple diffusion. In simple diffusion, No carrier molecule is required, no channel is required. So that's why when we increase the concentration of substance, the rate of diffusion increases. No saturation occur out here. So this is about membrane transport. So moving further to some important questions. First question, for transport of a neutral substance across the cell membrane occurs via pouring, ionophores, lipopolysaccharides or diffusion. Transport of neutral substance across the cell membrane occur via. Everybody answer this question. Yeah, way true. It occur via the diffusion. Let's say for the gases, neutral substance like gases, it diffuse, it transport occur via this diffusion only. Answer is D. Very good. Coming to the next one, which of the following statement about a facilitated diffusion is true? It is a form of active transport. It required carrier molecule. Rate of transport is proportionate to the concentration gradient required creatinine phosphate. So everybody answer this question. Which of the following statement about a facilitated diffusion is true? Which of the following statement about a facilitated diffusion is true? Yeah, way to Dr. Kartika. Answer is B. It is a passive transport. It required carrier. Yeah, way to Dr. Apur, way to Dr. Ambuj. It required carrier molecules. So rate of transport is not proportionate to the concentration gradient. It doesn't require ATP, so it doesn't require the creatinine phosphate. So answer is B only. Coming to the next one. All of the following transport process follows saturation kinetics except facilitated diffusion, sodium calcium exchanger, simple diffusion, sodium coupled active transport. So everybody answer this question. Yeah, very true. Simple diffusion doesn't follow the saturation kinetics because out here no channels or no carrier molecule is involved. Coming to the next one, sodium potassium pump, the coupling ratio is 1 is to 1, 2 is to 3, 3 is to 2, 1 is to 4. For sodium potassium pump, the coupling ratio is, everybody answer this question. Yeah, way too. The coupling ratio is 3:2. 3 sodium is pushed outside and 2 potassium move inside the cell. Coming to the next one. This is a nice question to everybody. True about sodium potassium pump is that it involves EDPase activity. It can move the sodium in and out of the cell electrically neutral. It pump out 1 sodium for 1 potassium. It pump 3 sodium and 2 potassium inside the cell. So everybody answer this question. Which of the following statement regarding sodium potassium pump is true? Everybody answer this question. Yeah, way true everybody. That's great. Answer is A only. It involves ADPase activity. It is a classical example of active transport, the primary active transport. So it required ADP, so it involves this ADPase activity. ATP binding site is present at intracellular position of alpha unit. It doesn't move sodium in and out of cell. It moves sodium only in and out of cell. It is moving 3 sodium outside and it is moving 2 potassium inside. So that's why it is not electrically neutral. So these all options are wrong. So answer is only and only A. Very good everyone. Coming to the next one. Take me to one more important question, all of you. Okay, fine. Coming to this one. Which of the following increase particle diffusion across the cell membrane? Increasing the size of particle, decreasing lipid solubility of substance, increasing lipid solubility of substance. Option E, decreasing size of opening in the cell membrane. So everybody answer this question. Which of the following increase particle diffusion across the cell membrane? Yeah, very true. Very good, everybody. Answer is increasing the lipid solubility of substance, because the fixed law state that, what is the fixed law state? It states that diffusion is directly proportional to the concentration gradient. It is directly proportional to the lipid solubility of substance, and it is inversely proportional to the size of molecule it is in membrane. So that's why answer is only and only C. Very good everyone. Coming to the next one. Taking to one more important question. All of you. Okay, fine. Coming to this one. Secretory vesicle are transported. Along gradient, against gradient, maybe along or against gradient, have no correlation with this concentration gradient. So everybody answer this question. Secretory vesicle are transported. secretory vesicle are transported. Option A along concentration gradient. Option B against concentration gradient. Maybe along or against concentration gradient have no correlation with the concentration gradient. Everybody answer this question. Secretory vesicle are transported. See, the secretory vesicle are transported via which transport process? Anybody? We are talking about which transport process out here? That is exocytosis. Is this clear? This point, is this clear? The secretory vesicle is formed in the exocytosis. So we are talking about this exocytosis. This exocytosis is have no correlation with the concentration gradient. When certain, remember the regulated pathway? What happened? When there is a certain signal in the form of hormone, suppose in the form of hormone, there will be this exocytosis. No, it's not against gradient, not along the gradient. Whenever there is a signal, there will be this exocytosis. It has no correlation with the concentration gradient. Is this clear with everybody? Is this clear, Dr. Santosh? Is this clear, Dr. Kartika? Okay, fine. Moving to the one more important question. Okay, that's all. Yeah, one more important question. Let me take you to this one. Which of the following is used in exocytosis? So, calcium, magnesium, sodium, or potassium? Which of the following is used in exocytosis? Everybody answer this question. Yeah, very true. Increase in intracellular calcium is required for this exocytosis. I hope concept clear हुआ होगा everybody. All the concept regarding this membranal transport is clear with everyone. If anybody has any doubt, you can ask. Hope you all like the session. If you like the session, do like and share. This is important. जितना ज़्यादा share करते हो उतनी ज़्यादा class interactive होती है. So do share everybody and subscribe our channel, that is Unacademy Light NEET. Unacademy Live NEET PG. Subscribe our channel if you haven't subscribed yet. Do subscribe and press the bell icon so that you'll get notification of every class and you won't miss a single class. That's all for today. Thank you so much for joining. See you all in the next session. Okay, that's fine, Dr. Yadav. That's great. So see you all in the next session. Do hard work. Your hard work will definitely pay it off. So let's crack it together. Let's crack your first professional examination with good marks, and let's crack your upcoming next examination, that is NEET PG examination also. So that's all for today. Thank you so much everybody for joining. See you all in the next session. This is the code Dr. Nidhi. If you want to join any paid course, you can use this referral code to get additional 10% off. Do remember the code, that is the Dr. Nidhi. If you want to, if you have any query regarding anything related to our physiology topic, you can ask me on Unacademy. My page on Unacademy is unacademy.com/@KGMC. You can follow me out there. Most welcome everyone. You can follow me on Unacademy also. My page on Unacademy is this one. You can ask any doubt regarding any topic related to the